My name is Oleg Marichev, and we present advances in Mellin integrations, in Mellin-Barnes integrations. Near me, you see Paco Jane, who works with me many years in Wolfram research. And I should say, just beginning, the following. Practically all integrals which exist in literature, in handbooks, and successfully evaluated belongs to such class, Mellin-Barnes integrals. But people does not know this. And in our talk, we try to open some important secrets which allow to understand structure and reason why so many integrals were evaluated and presented in numerous handbooks. I am author and co-author of 25 books if we take into account translation. Basically, it's more than 10 books translated on different languages, including Chinese, Japanese, English, of course, from Russian. And we start talk from showing big thankful to our colleagues Marco, Lou, and Daniel, who provides very impressive integral evaluation opportunities and programs which I try to demonstrate you for beginning. No, for example, first one, we have functions which is kernel of Riemann-Liouville, kernel as a transform Bessel K, and FoxH function. And we, using this program, can evaluate structure of this kernel. Below you see gamma functions which placed inside, and this is structure of coefficients of these gamma functions. Other program is demonstrate plot, interactive plot picture which was done by Marco. You see poles for gamma functions and everything done for function which is here. And this is Mellin integral representation of this function. And here you see that curve goes, separate left poles from right poles. Right poles goes to right direction. But of course, in short time, I cannot place so much in many information. And by this reason, let me shortly tell, you can read here information about how Mellin-Barnes appeared. Mellin-Barnes integrals appeared. The first publication was in this year, and then function by name Meyer G function appeared, FoxH function appeared in 61, and then we see different style for description of these functions, and here you see literature, my book and translated book, and below in references you can find exact list of these publications, and here at last we can see examples that functions like power function and exponential function, particular representable through FoxH function. What is it, FoxH function? Now I don't show here, but below you will see in our representations. And no, for example, exponential function can be represented through FoxH function in such manner. We can go further, and here you see opportunity how gamma function appeared. It is Mellin transform from exponential function, and exponential function, very basic one, as you see here, because it's connected with one gamma function. But if we have products of gamma functions, we have more complicated original functions if we use such relations, which presented in this set of, we can run, let me go further, we can run list of such functions. Here you see 138 functions which Mathematica has, and all these functions representable through FoxH and Meyer G functions. And here, after several, just less than second, and we can evaluate such representations. You see these opportunities. You can rerun yourself this. In particular, on position 81, you see a situation when hypergeometric PFQ function representable through FoxH function, and this is inside characteristics of these parameters of these functions. Also, Mittag-Leffler function, famous, it is particular case of FoxH function. Sometimes I demonstrate how long time we need for such evaluation. Let me go further. So here you can find definitions of FoxH functions and other functions. I will not show these definitions, but you see titles, and here you can find what is it, Mellin transform. Again, Mellin transform, it is like absolute equivalent to Fourier transform, but we need to change variables, and we one-to-one can transform Fourier to Mellin and back. Then we can see that we can represent integrals from one Fox function and corresponding examples. This is generic formula. Integral equal to, here below, how to move? Here we go move down, and result for this integral is here. I don't give conditions for conversions, but it also it is known, and we can define this. And also we have corresponding formula with examples. Three examples. We can evaluate this gamma integral, more complicated integral from Mitter-Kleffler function, and much more. You see that G, it is the power of x here, G. G can be positive or negative. By this reason arise absolute value. I never saw that absolute value existed in such type publications of integrals. I together give about 10 examples here, but you can, for example, here we have integral from G function. G function, again, with conditions. We give conditions, three kinds, yes. And I will not go to further cases, integrals from 2 Fox and so on. I just go to next one. Next one, it is general formula. It's our big success that we in this year derive very generic abstract formula when we have integral from product arbitrary set of Fox functions. This is formula new, I never saw in literature. In particular, it includes Weber-Shafkaten integral. Yes. As case of this formula, I evaluate integral from 3 Fox function. And now I present our achievements which described will describe Paco using Packlet with functions.
Thank you, Oleg. So just a little bit more background that Oleg maybe didn't come out clearly in what was said already is that we've not only done the theory, Oleg has worked extensively on the theory behind integration using Mellin-Barnes integrals, but we've coded this and deployed it as a Packlet in the Wolfram Packlet repository. So this technology can actually be used to do a real integral. In fact, it can do many integrals, many thousands of them, and in fact, better than the built-in integrate in some cases. So I'm just going to give a small flavor of that. As I said, these things live in the Wolfram Packlet repository, so you can get them with a Packlet install call, which is given here, and then you just have to needs the appropriate context. That's given on the documentation page. If you go to the Packlet repository and search for special functions and calculus, that's the name of the Packlet. you will get instructions on how to install and load it. The Packlet includes a bunch of functions, one of which is called sample univariate functions. And the purpose of this one is to give examples of univariate functions that can be converted into MyRG or FoxH functions. So I've picked out this medium test set because these are a subset of the functions available that all have a MyRG form, and then I've eliminated the ones that have extra parameters in them. So this true univariate goes to true option gets rid of functions that may have external parameters so that we don't have to worry about instantiating those when we do our testing in what follows. This function is available also available not just through the Packlet, but as a standalone resource function. So you can call it this way. And it just gives a idea or a sampling of what types of functions are available that have these MyRG or FoxH representations. So just running it a few times, you can see the types of things you get back, elliptic integrals of rational functions, or actually that was an algebraic. So all kinds of different stuff. If you just play with this, you can see the wide variety of functions that this technology will work with. So now we're going to use the main function that is, I would say that maybe the most important function that is exposed by the Packlet, which is Mellin-Bard's integrate. So this is the one that is an implementation of the technology that Oleg has been showing so far. So in this example, we'll take a elliptic integral IE type function, we'll make it a little more complicated by multiplying by some powers, and then we'll do an integral. You'll see that here, when we use system integrate, we get a result, but it takes 45 seconds, which is a little bit of time. Mellin-Bard's integrate we can use, and it gets an answer almost immediately in less than a second. And these answers may not look quite the same, but if you use some identities involving the gamma function, you can see that they actually are going to give the same results. And I'll just show that numerically down below. If we do, first I did numerical integrate with N integrate, and then I did R routine and the system integrate, and you can see that they all agree with certain values of the parameters over here. In example 2, we have the product of a elementary or trigonometric function of a rational times an exponential of a rational, or an exponential of an algebraic, I should say. We can evaluate this integrand that again is even more complicated. Notice that we could eliminate, like if we set g equals 0 in this, we could send or alpha equals 1. We can simplify this function for certain choices of the parameters. If we do this with system integrate, we attempt it, it fails after over 2 minutes on my machine. But if we use Mellin-Bard's integrate, you get it in like 1/10 of a second. You get a result with conditions of convergence that you can numerically verify. So here we see N integrate and R routine gives matching values. Third example, just the same thing again, but this time uses an integral that has finite bounds from a to b instead of from 0 to infinity. And we see that again, system integrate doesn't give a result very quickly, but Marichev integrate, excuse me, I called it it was previously called Marichev integrate. That's why the symbol is named that. But Mellin-Bard's integrate gives quite a complicated result, but it takes, again, about 1/10 of a second to get. And again, numerically confirming the results here. And then a final example. I won't go through this one. I'll just leave it up on the screen while I make some few last remarks, which is the code that we've committed and pushed to the Packlet repository is not perfect. It fails in some cases. In some cases, it will throw messages. That's part part of the reason for that is that Oleg worked on the code and then gave it to me to deploy. So there was some things fell through the cracks, but I think this function is still really useful in a case where you want to do an integral, you want a closed form of the integral, and you can check it later with N integrate, but you want to get that closed form so that you don't just get a number and you can see how things vary with different parameter values. This is a very good routine to use for that sort of purpose. I'm going to hand it back over to my partner Oleg now.
Oh, yes. I can add the following maybe fantastical words that by my estimation during maybe 50 years of work with handbooks for integrals, we wrote 6 volumes basically. About 80% of all done integrals somehow belongs to this class, maybe after changing of variables and so on. By this reason, in my life, I want to realize project to evaluate practically all known and not known integrals. It's millions integrals automatically using this algorithm. And you see several levels algorithm. If we have integral from one FoxH function, we have as result gammas. If we have product two FoxH function, we have again FoxH function from these joint parameters. And if we have 3 FoxH function, result will be double Mellin-Barnes integrals and double series like Apple and more complicated Campi de Fourier functions. And this one we still don't have in Mathematica, but must have, I'm sure. And we will try to implement them. If you have maybe questions, we are ready to answer on these questions. And what I don't read.
First, there's one question here in the chat. Is it possible to generate proofs that a particular Fox or Meyer representation is e to the x or sine x? That's a great question.
Yes, of course, we can convert in both directions. And I demonstrated just small table, 138 functions, which exactly converts to FoxH and back. But my test includes about 4,500 cases, and we run this test during 1 minute. During 1 minute, we convert this 4,500 function into FoxH, and it means next seconds, minutes, we can convert to integral from FoxH. And then this each FoxH multiply on other each FoxH. It's 4,000 with each other. How many? You roughly see that's many millions, even in such level.
Just to more precisely answer the question, or at least sketch an idea of how the proof of these things would look. I've brought back up
residue.
I've brought back up this page of diagrams that show how the different Meyer-G and FoxH functions are defined. And basically a sketch of the proof is, you look at these complex contours, you decide in what direction you can close the contour such that the part at infinity goes away, and then you use residue theorem because these gamma functions that make up the the thing that goes inside the integral. So like if I highlight here, in this case, this product of gamma functions here, whoops, right here, has poles, that go to the left and to the right. So you close the contour in one of those two directions and then use the residue theorem to count up, and you get a series. The series you'll sum, and if you do it for like sine of x, you'll find that the series sums to the Taylor series of x.
Advise to read my first books, 78 year and translated 83 years on English version, 5 years later translated. And also volume 3, integrals and series, Prudnikov, Bryczkov, Marichev. You will find many information there. Volume Mellin transform, our recent book 5 years ago, Bryczkov, Marichev, Savichenko, CRC publishing house. Yeah.
We have another question. Could the Risch algorithm? Oh no, that wasn't the question. There was one before this question. Sorry. Could there exist a function even more general than FoxH so as to include as particular cases, e.g. Hoyne functions?
Hoyne is more complicated by structure because Fox function maximum Fox doesn't satisfy differential equation, but its case by name Meyer G satisfies differential equation. With 3 singular points maybe, or 2 singular points. It depends from parameters. But Hoyne function also solution equation, and this equation with 4 singular points details Tigran Ishkanyan can answer. He developed this function.
All right, we're at our time limit, but we do have more questions, so we can stick around. People can stick around if they do want to hear the answer to the last question. Could the Risch algorithm be extended to the full range of special functions?
I'm not sure, because Risch designed for rather elementary functions, as I understand, and it's very different areas. Yeah.
All right. Well, thank you for your attention, and talk to you next time.